There we go. So just like before, we can use proportions to solve this, right? Again, we want to know how many inches there are in 10 centimeters, right? So in other words, we want to fill in this blank. We want to find the number that goes into this blank. So we can use proportions. You don't have to, you could use the factor label method if you want to, but we're going to use proportions. So of course we need one of those unit conversions. So this is the one I chose. The other one is basically the same thing except it's inverted, right? So I'm using this one. So again, it's really from the definition, we have this unit conversion. So we have this ratio. Here's another ratio. Namely, we're given 10 centimeters, and we want to know how many inches that is. Okay, so we set them equal to each other. I mean, why are they equal? Well, because they both deal with converting centimeters to inches. And notice that in the corresponding spots, if you look across, that is, you have the same unit. Same thing down here. Okay. You want to make sure you have the same units in the same corresponding spot. So if you use the other unit conversion, the only difference then would be inches for you would be on top, centimeters would be on the bottom. Okay. But either way, so we get this proportion, and we want to figure out what is x. So what do? We cross multiply. That's what I'm doing here, right? Multiply, as you can see, right? That's how we get the left-hand side. Cross multiply, 1 times 10, or 10 times 1, same thing. Right? And we want to get x all alone, so we divide, as you can, what we're doing here. And so we end up getting x is this, and this turns out to be about 3.94 inches. I think someone in my other, this is what we get. Someone in my other class said they got 3.93. Remember, you want to round your answer to 2 decimal places. In the calculator, if you did this quotient, you would get 3.937 and a bunch of other stuff. Because of the 7, that's why the 3 becomes a 4. So this is what we get here. Okay, any questions? Okay, so let's keep going. Yeah, so this is about that much, yeah. Okay. All right, so now we're going to consider some word problems. And again, these are going to be rates, so we're going to solve these. So this one, I think, it's in the textbook. I don't remember what number or page it's on. At least I think it's in the textbook. But suppose we have 4 3-megawatt wind turbines, okay? They're able to supply enough electricity to power 3,000 homes. We want to know how many would be required to power 55,000 homes. So we want to know how many of these turbines could power 55,000 homes. Okay. All right, so we do have a rate immediately, right? One rate we get is this. We know that 4 of these turbines, I mean, probably should have been 3-megawatt wind turbines, 4 of those, but hopefully you get the idea. So we have 4 turbines are needed to power 3,000 homes. And we're dealing with those turbines powering homes. So 4 power 3,000, okay? The other rate we have is involving 55,000. Now, we don't know how many turbines are going to do that, and that's what we're looking for, right? We're looking for how many turbines would be required to power 55,000 homes. So I just wrote let X be that number. Then this is the other rate we get. So we want to know how many are needed to power 55,000 homes. That number is X. Okay, but these two rates are going to be equal to each other. Mostly because they're both dealing with those wind turbines, how many of them are needed to power homes. I mean, I'm sure if you do some fancy calculation from here, you can get how many one would power, but this is enough. So just like before, we have these two rates. They're equal. Now we want to figure out what X is. Again, notice the units are the same. Excuse me, units and corresponding positions are the same. You know, if you go across, you get the same unit, like so. So now we solve this proportion. Okay, I just took the units away. So now we have this to solve. And what do? Well, we can cross multiply. So we have 3, so cross multiplying, this should have come first, sorry about that, but we have 3,000 times X equals 55,000 times 4. 3,000 times X equals 55,000 times 4. That's what we get here. And then this step, I know it goes backwards a bit, sorry about that, but we're dividing by 3,000 to get X, and that's how we get X. And it turns out when you do this calculation, you get about 73.33, and I rounded it to 0 decimal points because we're looking for the number of turbines. So I just wrote 3 megawatt turbines. That's what I did. So again, I would tell you how many decimal points to round to. Okay. So that's what we get. So again, it's just another proportion. That's all it is. Okay. All right, so that's one word problem. Let's do some others. Here's another one with lemons. In my other class, there was a mistake in this, so I fixed it. But let's do this. So, you know, we have a store selling lemons. You get 2 lemons per dollar. Each lemon, you know, somehow we're able to use the right juice or whatever, but we can get 2 tablespoons of juice from each lemon. And basically, you can read it, but basically what they're asking you is, how much is it going to cost to get 10 tablespoons of lemon juice? You know, we want to buy enough lemons to squeeze out 10 tablespoons of lemon juice. How much is that going to cost? So notice there's actually 2 things we're looking for here, right? We want the number of lemons and the cost. So what I'm going to do first is get the number of lemons. So I'm going to call that X. So X is how many lemons we need to make 10 tablespoons of lemon juice. That's what I'm doing first. And we have a rate that can help us with that, right? We're told that each lemon gives 2 tablespoons of lemon juice. So I wrote that, so that rate, this way. 2 tablespoons we get from a lemon. You could have flipped this if you wanted to. You could do 1 lemon over 2 tablespoons. You could do that if you want, as long as they're consistent with the units. So X, again, is how many lemons we need to make 10 tablespoons. Well, if 1 produces 2 tablespoons, right, what must happen is X will produce 10. That's how X, you know, that's what X is. And both ratios here, they're dealing with, you know, getting lemon juice from lemons. They're both going to be equal to each other. So from here, what are we doing? So we have these two rates. We set them equal to each other. Now we have to figure out what x is. Okay, so what do? We have the units are gone, they cancel, and now we just cross multiply. Again, I don't know everyone's math background, so that's why I'm going through all the steps. But now we cross multiply, we get 2 times x. That's here. 1 times 10 is 10. And then we divide by 2, and we get x is 5. So we need, we need 5 lemons. Okay? We need 5 lemons. Okay? And again, let me say it again. These ratios are equal, mostly because we're getting lemon juice from the lemons. Both of them deal with how much lemon juice we can get from lemons. I mean, here we want 2 tablespoons. Here we want 10. And we found that x has to be 5. But we're not done yet, though. Not only do we have to get the number of lemons, we need to know what the cost is. Now, you could get the cost easily using the factor label method. I'm going to use proportions just to be consistent. So now x was something else, so I don't want to use x again. So I'm going to say let C be the cost of 5 lemons. Okay? Well, then we know that 2 lemons cost $1. We want to know the cost of 5 lemons. So 5 lemons is going to cost C dollars. But again, this deals with the cost of lemons. Both ratios do, so they're equal. And now what do we do next? Well, we want to get C, right? I mean, again, X denoted something else, so I'm using C. So what do? We now want to figure out what C is. And the mistake I actually made in my other class was I actually mixed up the units here. I had 1 over 2 instead of 2 over 1. But here it's right. So just like before, the units are gone. We have to figure out what C is. So from here, right, we cross multiply. We get 2C on the right, 5 times 1, which is 5 on the left, as you can see. But again, we want C. We don't want 2C, so we divide. And we get the cost is $2.50. Okay, good. So we get $2.50. Okay. Let me just pause the recording. But are there any questions on that?